Are you tired of those not straight lines? Tired of stressing over homework? Well, stop, because with the box, you'll never have to cry over math homework again. The box is a smart device that will help you solve anything from basic math to piecewise functions and even beyond. Have a problem you can't solve? Just ask the box to assist you. It will give you grade A help for those straight A grades. Just look at it go. Spectacular. To activate the box, just say, "Hey box."
Hey box.
The box is even smart enough to help the smartest of the smart. Just watch it help this student integrate this function. Amazing! Now let's learn about piecewise functions.
What is a piecewise function? Well, a piecewise function is a function defined by different subfunctions, each subfunction applying to a certain interval of the main function's domain. Take this function for example. This piecewise function is defined by 3 subfunctions. Each subfunction has a certain interval of the main function's domain. Now I will help this struggling student graph this piecewise function and determine its domain, range, and intercepts. The first subfunction is a cube function. The equation for this function is f of x equals x cubed. The domain and range of a cube function are the set of all real numbers, and it has an intercept at the origin. To start graphing this subfunction, Joseph will plug in numbers to the function that are less than or equal to -1, since the domain for the subfunction indicates that x is in this interval. Here you will see Joseph plot coordinates with x values less than -1. Notice when Joseph plots the coordinate with the x value -1, he uses a closed circle. That is because the domain was less than or equal to -1. After plotting enough coordinates, Joseph will now connect them. He stops the graph at -1, 8 because the domain cannot go further than -1, and he draws the other end of the graph with an arrow because the domain includes all values of x for and under -1. The second subfunction is a constant function. The equation for the function is f of x equals b. The domain of the function is all real numbers and the range consists of a single number b. The intercept of this horizontal graph is also b. Though the domain is greater than -1, Joseph will still plug in -1 and graph the coordinate. He will use an open circle, however, because x is not equal to -1. He will then draw a horizontal line until the x value of 2, because the domain also says x is less than or equal to 2. Because it is equal, Joseph will then use a closed circle. The last piece to the function is an absolute value function. The equation for the function is f of x equals the absolute value of x. The domain of this function is all real numbers, and the range is a set of non-negative real numbers. The intercept of the graph is at the origin. Joseph will begin to plug in x values that are greater than or equal to 2 and less than 5. Remember, since x can also equal 2, he uses a closed circle for 2, 2, and since x is less than 5, he uses an open circle for 5, 1. Congrats! The graphing is all done. Now the last step is to determine the domain, range, and intercept. The domain of a graph is all of the x values. Since the domain stops here and does not include 5, but continues to the left forever, it is x such that x is less than 5. The range of a graph is all of the y values. Since the range starts here and includes 7 and continues down forever, it is y such that y is less than or equal to 7. Intercepts are points that touch the y-axis or x-axis. The x-intercepts would be 4 and -2, and the y-intercept would be 2.
So now you can stop stressing over homework and start finishing them with ease. The box, a simple solution to a piecewise function.